The following program is a special presentation of the Big Ten Network, produced in association with the University of Wisconsin.
Conventional wisdom has long held that babies were, well, babies, oblivious to what was going on around them and learning little in their first year of life. In recent years, however, a series of new studies have demonstrated that very young children are much more engaged than many experts had thought and have the ability to observe and learn from the world around them. So is your baby smarter than you think? Join us next during office hours to find out. Hi, I'm Ken Goldstein, Professor of Political Science at University of Wisconsin-Madison. Joining me today on office hours to discuss recent findings in early childhood development and what it might mean for your children or grandchildren is Dr. Jenny Saffran, College of Letters and Science Distinguished Professor of Psychology and an investigator at the Weizmann Center here at UW-Madison. Her lab, the Infant Learning Lab, has an international reputation in the area of developmental psychology, and she has received a number of major awards, including several early career awards from the American Psychological Association. Not only tops in the lab, Dr. Saffran has also received several teaching awards on the UW-Madison campus. Jenny, thanks for joining us here
It's a real pleasure.
Office Hours. So we're going to have a conversation about your research and all of this new research, which is in reaction to this conventional wisdom that, as we put it in the intro, babies were babies. As I was doing my homework that you gave me for the show, I got to say I was shocked that that conventional wisdom even existed. So could you sort of talk a little bit about what those touchstone pieces of research or conventional wisdom was that you and many other younger colleagues are reacting to?
Well, Ken, I think there's a very interesting history in thinking about our understanding of how our babies learn and what our babies' world is like. So on the one hand, if we go back 100 years, we have scientists, philosophers who would suggest that a famous quote is, "The baby's world is a blooming, buzzing confusion." Basically, the baby is there, the baby's a little lump, and there's all this stuff going on, these sounds, these sights, these smells, and somehow the baby has to figure out how to interpret those. But in those earlier ways of thinking, it wasn't thought that babies could do much about it, right? And on the other hand, there's been this view that the baby comes with all these factory installed abilities, and that the baby actually knows a lot more than you would be able to see on the surface. Our own focus in my lab and in many other labs around the country is to try to put those two areas together and to be able to say, wow, the baby's world is incredibly rich. And maybe babies aren't just born with a tool set, but they're actually born able to make sense of that world and be able to use what's going on in their environment to move them forward. And so this has led to a real emphasis on learning, a new emphasis that wasn't there even 10, 15 years ago in the field.
So sort of two things you're reacting to. One, this notion that babies are just blobs and everything's a buzz, and if they're smiling at you, it's because they have gas, not because they're actually smiling at you.
Which is probably true at a certain age, but yeah, I hate to tell you.
And then you're also reacting to the work of a Noam Chomsky, who suggests there's this hardwiring that in a kid's brain that automatically takes place.
Right.
So tell me about some of the major findings in the field that have cast doubt on that conventional wisdom.
Well, part of why we can now ask these sorts of questions is because people have developed ways to test babies. So if you remember when your children were babies, you know, they're cute, they sort of sit there a lot. You as their parent have this sort of instinct of thinking they're really smart and there's a lot going on in there, but they're not saying anything, right? They're going ba, ba, ga, duh, right? Until, you know, you get that magical first word at 12 months or 15 months or 18 months. And so, because it was very hard to know what was going on in their heads, it was easy to believe either there was nothing going on in their heads or everything was built in, because otherwise how would they know so much when they do start to talk, right? So some of the findings that have emerged over the past decade or two have come out of our ability to develop methods to test babies to understand what's going on in their minds. So I'll give you just a single example, not from my lab, but one of my favorite examples to illustrate just how smart babies are about learning. So we know that when babies are very, very small, between 0 and 6 months of age, when they hear sounds from any language, they can tell the difference between them. So a Japanese baby can tell the difference between ra and la when they're 6 months of age. But by the time babies are 10 to 12 months of age, they can no longer tell the difference between sounds that are not in their language. So a 10-month-old Japanese baby can no longer tell the difference between ra and la by 10 months. Similarly, you and I assume you don't speak Hindi.
No.
I don't either. But when we were 6 months old, we could tell the difference between, I'm going to try to get it right, a sound pairing in Hindi, da and da. So when you were 6 months old, you could hear the difference between those sounds. But by the time you were 10 months old, you no longer could. What changed? Well, it's not that you were running around saying da, 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 or ra, la. It's that you were actually picking up on the patterns of sounds that you heard in your world. And by 10 months of age, before you could make those sounds, your brain was being tuned to perceive and process the sounds in your native language. So it's that sort of study, which of course relies not on what babies are saying, but using methods that allow us to tell what they're thinking, that allows us to see some of this incredible development that's occurring during that first year of life.
Talk to me a little bit about some of these methods, because as I was doing my homework, some people were making the point that the existence of cheap video recorders made some of this research possible, because you could then tell what the babies were doing, since you can't ask them or give them a survey like I do.
Right, right. So it's a combination of having simple things like, video that's digital that you can manipulate. So in the kind of study I was just talking about, the way those sorts of findings were discovered initially was actually very clever. Babies were hooked up to a pacifier, and the babies were given a pacifier that was in turn hooked up to a way of presenting sound, to a loudspeaker. And when the baby sucked on the pacifier, a sound would be presented. So suck, ba, suck, ba. So as the baby sucked, they would get to hear the sounds that they wanted to hear. And babies like to hear ba, so they would, or let's make ra, la, because it's an easy example. Suck, ra, suck, ra, suck, ra. After a little while, the babies get bored. So they start sucking more slowly. Suck, ra, suck, ra. And then the researchers would change the sound. And they'd either play a new ra or a la. And if the babies can't tell that it's now a la, then they're still going to go suck, la, suck, la. But if they can tell the sound is switched, you'll get suck, la, suck, la, suck, la. And so this very simple kind of technique allows you to tell whether the baby can tell the difference between two things. You can do that with a 1-month-old, but you can do that with a newborn even.
So it's interest or attention is then your indicator that they can recognize that word. Okay, let's come back and talk about all the different ways that we can look at interest, attention, and talk about some of your research. Please stay with us on Office Hours, and we're going to continue our discussion of baby development and is your baby smarter than you think?
This program is a production of the University of Wisconsin-Madison. If you have comments about this broadcast, please email them to programming@uc.wisc.edu.
For more than 100 years, the University of Wisconsin has been inspired by the Wisconsin idea,
which says the good work of the university extends to the boundaries of the state and beyond.
So the UW works hard to help build Wisconsin's economy.
Educate people of all ages.
Advance health and medicine.
And enhance the quality of life for all of us.
Hit it!
The University of Wisconsin-Madison. Forward thinking.
Welcome back to Office Hours. We're discussing early childhood development with Dr. Jenny Saffran of the University of Wisconsin Department of Psychology. Okay, Jenny, I've read that you're someone who's known or been a pioneer in statistical learning, that babies engage in statistical learning. What does that mean?
Well, what it does not mean is that babies are sitting around doing the stuff that your undergraduates do in their introductory statistics classes. It's actually a very simple idea, but I think it's very powerful. The idea is that part of how we learn, particularly when we're very young and we don't know very much, is by keeping track of patterns in our environment. So keeping track of what predicts what, or what things co-occur together. Those are statistics. Now, they're sort of pretty simple statistics, probabilities and frequencies. But if you look around the environment, I study language primarily, there are a lot of examples there, but even look at caregiving and how an infant might begin to pick up on the fact that their cries lead to their parent showing up, or perhaps worse, that if they get held, if they can't fall asleep, they get held, which, as we know, can sometimes make it hard to put a baby to sleep. So it's a very general idea, and there's a lot of reason to believe that, in point of fact, our brains, us and many of our non-human relatives, our brains are exquisitely attuned to the statistical properties of our environment.
So another way of putting it is babies are relentlessly testing, experimenting, looking for causal relationships. Would that be fair?
That would be fair. They seem, their attention seems to be captured by situations where there's some level of uncertainty, but where they have some control over the situation. So that would be sort of the example you give of finding causal relationships, which is what science is about, right? They also seem to do it in a more passive way. So in our experiments on how babies learn language, we've found that we can get them to pick up on things like the probabilities with which sounds co-occur with one another, or the probabilities with which sounds co-occur with objects, as a simple way to figure out which sounds belong together as words and then which sounds are labels for which objects. So without rewarding them, without giving them instructions, you can't tell an 8-month-old, okay, keep track of the probability with which bay predicts B. You can't tell them that, but their brains just seem to soak up that information.
Say a little bit more about that.
Yeah.
How do we know that?
Okay, well, this goes back to these lovely methods that have been developed for getting inside babies' heads. So in some of the experiments we're doing in our lab right now, what we do is we bring babies in. Very kind parents will bring in their 8-month-olds for these particular studies. And we're looking at how babies figure out where one word ends and the next one begins, which, if you stop to think about it, seems trivial when you know a language, but we don't talk like this. There are no silences between words.
And we've all had that experience when we think we've learned a language and then we turn on the radio the first time and it's like that.
And people always say, oh wow, people speak so fast in another language. It turns out that all languages are roughly the same pace. It's just when you don't know them, they seem really fast. So what we've been doing in the lab is we've been bringing babies in and playing 2 minutes of Italian to them. So they're listening to someone speaking Italian, which I don't speak very well, so I'm not going to give you an example. And within the Italian, we've intentionally put words together so that some syllables predict other syllables well. Like if they hear ka, they're going to hear za, casa, house, quite frequently. So they sit, they come into our lab, and they're sitting on their parents' lap in a little room that's very quiet. And we have little motorcycle lights that are mounted on the sides of the room to get the baby's attention, and a little light in front as well. And what we'll do is the baby will come in, and for 2 minutes they'll hear this lovely Italian. Then the room goes silent, and a light will start to blink in front of the baby. We use that to get the baby's attention. Babies love blinking lights. So the baby will look at that blinking light, and when they look at that light, we extinguish the light. We know they're ready. We'll turn on a light on the side of the room. When they look at the light on the side of the room, a sound will start to play from that side of the room. So they'll hear casa, 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 and they get to hear it as long as they keep looking. When they look away, we turn off the sound, we turn off the light. So the baby's the boss. We play each sound as long as they want to hear it. And we alternate between sounds that were words in the language they were listening to versus sounds that they heard but that weren't words. Maybe sounds that go across a word boundary, like in English, T-bay between pretty and baby, which don't have as good statistics. The co-occurrences, the probabilities are less. And we simply measure how long the babies want to listen to those two types of sounds.
Excellent. Italian, a beautiful language with great pitch, and we're going to talk about your research on pitch in a second when we come back to Office Hours. Welcome back to Office Hours. So Jenny, one of your major research findings were that babies have perfect pitch. First of all, what's perfect pitch?
Okay. Well, in the sort of way you usually hear people talk about perfect pitch is this idea that I say to you, sing an A, and you go, la, which I think is an A. That's perfect pitch. Now, we can't do that with babies, because we can't say to a baby, sing an A, and a baby doesn't have a mapping between the sound and the note label anyway. So what we've been studying is whether babies have what's called absolute pitch, which is memory for the pitches they hear, but not the labels. And it turns out, interestingly, well, there are two interesting things to say. One is that it turns out that babies seem to be better than adults at remembering the pitches that they hear. That is, if I play a baby 2 minutes of a sequence of notes that has some statistics in it, again, certain notes go with certain other notes, and then I test them, or I test you, the babies will be better at remembering that they heard A, C sharp, D repeatedly than you will. You're better at remembering that you heard a major third followed by a minor second. We as adults are typically better at remembering the intervals between the notes.
Okay, so help me understand this as a non-musical person.
Yeah.
So adults are better at understanding musical notes in context? Would that be a correct way of saying it?
That's one way to think about it. Well, let me give you an example to make it clear. When you hear a song like Happy Birthday, the reason you and I can recognize that no matter who sings it, whether, you know, a 5-year-old sings it in a high pitch or a deep basso profundo sings it, is because what you remember about Happy Birthday is the distance between those notes. Whereas what babies seem to be better at than adults is remembering that they heard an A, like the actual note, followed by a C sharp. And they might be confused when they hear the same song in different pitches. Now that said, it actually turns out that adults are still good, even non-musicians. If I brought in, I don't know what a TV show is you like a lot, maybe the Office Hours theme song. And I brought in the Office Hours theme song and I played it for you on the right pitches or off by a half step, so just a little bit off, you'd be able to tell. So even adult non-musicians still can remember for very familiar music, whether they're hearing it with the right pitches or not. But babies can do this with novel music.
Okay. So what?
So
what does that tell us?
Well, one thing it tells us is that babies have some auditory perception abilities in common with birds and monkeys, because it turns out that the way our auditory brains work in other species, the way that it works in other species is often to remember the actual notes. The other thing it tells us is that we've learned, we've changed. Because if you went through life remembering, oh, I heard A, C sharp, but now you're singing that song and you're telling me it's Happy Birthday, but it doesn't sound like Happy Birthday to me, it's the wrong notes, life would be very confusing. Similarly, if you heard the word cup and then you heard the word cup, and all you did was remember the notes you heard, you'd have a hard time remembering those were the same notes, same words.
And does this have implications for what we were talking about previously in being able to distinguish words from streams of sounds?
Well, it does turn out that babies learn better when you talk like this than when you talk like this. So
all that baby talk, which sounds mildly annoying, they actually like?
Well, there are a number of things to say about that. They like it better even as newborns. They will pay attention longer when we talk to them with this big pitch changes. They love that.
Sing-songy,
even newborns.
Exaggerated.
This isn't my own work, but other research has shown that even newborns like to listen to that, and it makes sense. It grabs your attention, right? I've tried it with my undergraduates, though. They don't like it much.
They don't like that so much.
In our lab, we did some studies where we took one of these languages, trying to figure out where the word boundaries are, where one word ends and the next one begins, and we tested some babies with speech that sounded like go la ti bo fo pa boo da da, and we tested other babies with speech that sounded like go la ti fo pa boo da da da, and it turns out babies learn better when the speech is up and down. We think because it's drawing their attention in. In other recent work, we found that babies remember lists of words better when they're sung than when they're spoken. So if babies hear 97315, they remember it better than 97315.
Interesting. When we come back for our last segment on Office Hours, we're going to talk about some of the implications of this research. Please stay with us.
For more than 100 years, the University of Wisconsin has been inspired by the Wisconsin idea,
which says the good work of the university extends to the boundaries of the state and beyond.
So the UW works hard to help build Wisconsin's economy.
Educate people of all ages.
Advance health and medicine.
And enhance the quality of life for all of us.
Hit it!
The University of Wisconsin-Madison. Forward thinking.
This program is a production of the University of Wisconsin-Madison. If you have comments about this broadcast, please email them to programming@uc.wisc.edu.
Welcome back to Office Hours with Dr. Jenny Saffran of the Department of Psychology here at University of Wisconsin-Madison. So Jenny, let's talk about what some of the implications, or what some of the implications aren't for your research. So you've disagreed with this conventional wisdom that babies are they're blobs, that they do have the ability to learn. Mm-hmm. It's probably the case that maybe some parents take that too far. It does not mean that if at 6 months your baby is not doing X, Y, or Z, not listening to Mozart, not doing math problems, that there's going to be long-term damage. But it's certainly the case that some parents take these findings directly or indirectly and say, wow, from day one, we better be careful what we say, and we better be giving them lots of enrichment. Talk to me about that.
I think it's a really hard time to be a parent. I know when my kids were babies a few years ago, I felt very stressed by some of the societal pressures to do just what you said, despite knowing the data. I guess what I would love people to think about is just how rich the environment is. I mean, if you stop and think about yourself as a baby, think about this flow of language over you, the music that's already flowing through your environment, the faces, the smiles, just the wealth of experiences that comes from, you know, chewing on an empty paper towel holder. I understand the pressures to try to push children ahead, but I think that there's no doubt that play and just the wealth of social experience that is within the reach of most families is going to be, in many ways, the most important thing.
So the statistical learning or experimental learning is play, not sitting down learning.
No, I mean, the babies are experimenting. They're trying to figure out how their world works. We can't tell them how their world works. I mean, I can't walk up to a baby and say, "the" is a word and "elbow" is a noun. I mean, they have to figure that out. And they do, for the most part. And if they're not, then we know how to get them help.
Now, is this just babies? At what age do we stop learning by playing? Do we ever stop learning by playing and experimenting?
We never stop. I think adults, our problem is that we're too self-conscious about it. And we know, for example, that it is much harder for adults to do things like learn a foreign language. And some of that might be because it's hard for us to let go and crawl around on the floor and chew on paper towel holders. But I don't think that goes away.
We have very little time left. I've heard your research described as revealing the false dichotomy of nature versus nurture. So I'm sorry to do this the last minute, but what does that mean?
I study learning, and you can't learn without nurture. You can't learn without experience, but you also can't learn without nature. You have to have something that's in your head from the get-go that allows you to make sense of your experiences. So I view learning as the necessary bridge for what's factory installed and what's in your world around you.
Jenny, pleasure having you here today.
Thanks so much for having me.
Everybody enjoyed, parents, grandparents, would-be parents, children, enjoyed this discussion of early childhood development. From the University of Wisconsin-Madison, this has been Office Hours. Thanks for stopping by.
The preceding program was produced by the University of Wisconsin in association with the Big Ten Network.